A book exists that no human alive can read. Its pages are a gallery of impossible plants and cryptic scenes, a 15th-century-old volume known as the Voynich Manuscript. This is just one of history's most enigmatic manuscripts, texts so perfectly locked that they have resisted every traditional key. By the end of this, you will understand how scientists are using artificial intelligence and particle beams to finally have a conversation with the silent past. We will see how a single page can hide a lost language, and why a manuscript's illustrations might be a map to a forgotten world. What do you believe is the most profound secret a book could keep? That moment of profound confusion is the true signature of an enigmatic manuscript. It is not simply a matter of faded ink or archaic words. It is a complete system of communication that stands outside every known library, every deciphered grammar. The scholar recognizes letters, but they form no words they have ever seen. They recognize drawings, but the plants have no roots in any known botany. This is a different category of mystery altogether. As expert cryptographer Dr. Ilonka Dunin has pointed out, the most formidable puzzles are not those with complex locks, but those where we cannot even find the door. We do not know the language, the alphabet, or the fundamental intent behind the symbols. Is it a scientific treatise, a religious text, a work of philosophy, or an elaborate hoax? The manuscript refuses to say. This defining trait of absolute resistance is what separates truly enigmatic works from merely old or difficult ones. Consider the notebooks of Leonardo da Vinci. He wrote in fluent Italian, but he used mirror writing and his own personal shorthand, creating a layer of privacy over his brilliant ideas. The code was a filter. With the Voynich Manuscript, or the later mystery of the Codex Seraphinianus, there is no known base language to even begin filtering. The script itself is the invention. This transforms the book from a container of information into an object of pure intellectual defiance. Its significance shifts. We are no longer just asking, "What does this say?" We are asking a far deeper, more haunting question. What kind of mind creates an entire language for a book that no one else is meant to read? The value lies as much in the sustained challenge as in any potential secret. These books become mirrors, reflecting back the hopes, biases, and relentless curiosity of every generation that tries to crack them. They are beautiful, frustrating, and profoundly human artifacts. To understand their power, we must turn to the one that started it all, the manuscript that has become the archetype of the unreadable book. Its pages feel like a glimpse into a parallel world. Imagine opening a medieval guide to medicinal herbs, only to find every plant is a complete fabrication. The leaves curl in ways no real leaf ever has. The roots twist into ornate, impossible knots. This is the visceral experience of the Voynich Manuscript, a codex that has earned its title as the world's most mysterious book. Its story in the modern era begins in 1912, when a Polish book dealer named Wilfred Voynich discovered it in a European library. He was captivated, and the manuscript has carried his name ever since, a permanent guest in the Voynich Rare Book and Manuscript Library at Yale University. Science has since given us a firm anchor for its age. Careful carbon dating places its creation in the early 1500s, on fine vellum that has survived the centuries. It contains about 240 pages, each filled with flowing, elegant text in a script that belongs to no known alphabet, but it is the illustrations that first seize your attention. Alongside strange astronomical charts and intricate biological diagrams are page after page of those bewildering plants. This herbal section is not just a collection of odd drawings. The plants are rendered with a meticulous, almost scientific detail, which makes their total defiance of nature all the more unsettling. They possess a haunting internal logic, as if the artist was documenting a genuine flora from a world we cannot visit. This visual coherence is the manuscript's greatest tease. The text flows with natural patterns, with words that repeat and structures that suggest grammar. It looks and feels like a real language, which is why the theory that it is merely an elaborate, meaningless hoax has never fully satisfied experts. Could it be an encoded pharmacopoeia, hiding revolutionary herbal knowledge behind a cipher? Or perhaps a creative work of speculative fiction from a medieval mind, a botanical fantasy? For decades, linguists and codebreakers, including teams from both world wars, have tried to map its strange glyphs to every conceivable language, from a highly abbreviated Latin to a lost dialect from across the Atlantic. Each attempt has crumbled under scrutiny. The manuscript absorbs every effort at translation and gives back only silence. This botanical puzzle, so beautiful and so perfectly locked, forced researchers to a fundamental realization. To understand the book, they first had to understand the object. The quest would have to begin not with linguistics, but with physics, by asking what the manuscript is literally made of. The book's silence begins to break in the laboratory. Before a single word can be understood, science asks a more fundamental question: what is this object physically, and when was it born? This investigation moves the manuscript from the quiet of the library shelf into the precise light of the laboratory. Here, a fragment of parchment no larger than a grain of rice becomes a time capsule. The technique is radiocarbon dating, which reads the faint atomic clock inside all organic matter. All living things absorb a radioactive form of carbon, carbon-14, from the atmosphere. When life ends, that absorption stops, and the carbon-14 begins to decay at a steady, measurable rate. By calculating how much remains in a sample, scientists can pinpoint its age. In 2009, researchers performed this test on tiny samples of the Voynich Manuscript's vellum. The result was a definitive window, placing the book's creation between 1404 and 1438. This was a pivotal moment. It conclusively proved the manuscript was a genuine artifact from the early 15th century, not a clever later forgery. The physical book was authentically old, which meant its mystery was too. But material science goes much further than just dating. It seeks to understand the manuscript's very substance. Using tools like multispectral imaging, researchers can photograph the pages under different wavelengths of light, from ultraviolet to infrared. This can see beneath surface grime or detect chemical differences in the ink that are invisible to our eyes. It can reveal erased passages, or show the ghostly outline of a sketch that was later painted over. Microscopic analysis can identify the ink's composition, whether it is iron gall, carbon-based, or something more unusual. Each ingredient tells a story. The presence of certain minerals could hint at a specific geographic origin for the materials. This forensic approach has solved other historical puzzles. One famous case is the Vinland map, once thought to be a medieval depiction of the Norse exploration of North America. When scientists analyzed its ink, they found it contained anatase, a specific form of titanium dioxide that was not commercially available until the 1920s. The map was a modern creation, its secret revealed not by its content but by its chemistry. For a genuine mystery like the Voynich, this material profile builds an unshakable scaffold of fact. It tells us the object is real, its age is confirmed, and its physical story is waiting to be read. With the artifact firmly anchored in history, the next step is to look even closer, to use not just light, but particle beams to interrogate the very atoms on the page. The manuscript's atoms hold their story, but what if the story itself was never meant to be told? Centuries after the Voynich was created, another book emerged that deliberately courts the same profound mystery. In a studio in Rome during the late 1970s, artist and architect Luigi Serafini embarked on an extraordinary project. For over 2 years, he filled pages with watercolor illustrations of a universe born from pure imagination. The result was the Codex Seraphinianus, a modern encyclopedia of a world that does not exist. Its chapters document everything from the bizarre anatomy of its inhabitants to the surreal physics governing their reality. Fish evolve from light bulbs, lovers dissolve into alligators, and maps chart territories of pure pattern. Every image is rendered with the meticulous, clinical detail of a botanical or scientific textbook, which makes the utter absurdity of its contents all the more captivating. And flowing beside every illustration is a script of elegant, curling glyphs that look for all the world like a fluent, unknown language. Here lies the crucial twist. Serafini has openly stated that the writing is not a cipher. It is a form of automatic writing, designed to evoke the sensation of a child gazing at a book they cannot yet comprehend. The script has no syntax, no grammar, no hidden message. It is a beautiful facade of meaning. This modern artifact is not a puzzle to be solved, but a mirror held up to our own desire to solve. It acts as a vital control group in the study of enigmatic manuscripts. Scientists analyzing the codex are not trying to break a code. Instead, they study the composition of its modern pigments, the brushwork, and the deliberate artistic choices to understand how a coherent yet meaningless system is constructed. It demonstrates with perfect clarity what a work looks like when its primary intent is to evoke wonder and mystery, not to convey secret information. This forces a profound and unsettling question upon every researcher studying older texts like the Voynich. If a brilliant modern artist can create something that feels so authentically mysterious, so tantalizingly close to a real encrypted language, how can we ever be certain we are not chasing a phantom? The distinction between a lost language and an artistic exercise becomes terrifyingly thin. This question of intent of the creator's mind becomes the next great frontier. Once we have analyzed the physical book and considered the possibility of artistic invention, we must finally confront the script itself to see if the patterns within it whisper in a language we can learn to hear. The silent glyphs on the page begin to whisper when you know how to listen. This is the domain of the cryptolinguist, where a manuscript is no longer just a book, but a vast collection of data points waiting for their patterns to be revealed. The core idea is elegant and powerful. Every human language, whether spoken or written, leaves a unique statistical fingerprint. Think of the letter E in English. It appears far more often than the letter Z. There are rules, often unspoken, about which sounds or letters can follow others, creating a rhythm of redundancy and information that all natural communication shares. The first major scientific effort to listen for this rhythm in the Voynich Manuscript came from a Cold War codebreaker. In the 1970s, Prescott Currier, a United States Navy cryptanalyst, applied these statistical tools to the strange text. His analysis revealed something startling. The manuscript did not seem to be written in one uniform style. Instead, it appeared to be composed in two distinct statistical dialects, which researchers now call Currier A and Currier B. The character frequencies and word structures differed between sections, as if the scribe had switched between two related but separate modes of writing. This was not proof of meaning, but it was a profound clue. It suggested an underlying system with internal rules, a complexity that argued against simple nonsense. Later studies have pushed this analysis even further, using sophisticated computer models to search for the ghost of syntax, the skeletal structure of grammar that holds a real language together. Some models have suggested the text's patterns align curiously with certain abbreviated forms of Romance languages, like a highly condensed Latin. Other analyses, however, point in a more chaotic direction, where the patterns could be the product of a sophisticated code or even an algorithmically generated text. This stage of the quest is a meticulous process of elimination. Researchers are not yet translating, they are classifying. Is this the statistical footprint of a cipher where a real message is deliberately scrambled? Could it be a constructed language invented for secrecy or philosophy? Or does the data suggest an entirely lost natural language, one that left no other trace in history? Each theory must prove itself against the relentless scrutiny of mathematics. The patterns on the page are real, but their origin remains a haunting question. Are we hearing the faint, structured echo of a forgotten voice, or merely the convincing rhythm of a lock with no key inside? To move from pattern to possibility, we must examine the locks themselves, the historical ciphers that a 15th century mind might have used to hide a secret in plain sight. A simple substitution cipher feels like the most elegant solution. Picture a medieval scholar working by candlelight with knowledge too dangerous to write plainly. To protect it, he creates a secret key. Every time the letter appears in his Latin text, he writes a unique, invented glyph instead. B becomes another strange symbol, and so on. Anyone without the key would see only nonsense, while a trusted colleague with the same cipher wheel could translate it back, letter by letter. This was the first and most persistent hope for the Voynich Manuscript, that its beautiful script was merely a one-to-one mask for a known language like Latin or Italian. For decades, cryptographers applied this logic, mapping the manuscript's most common symbols to the most common letters in European languages. The result was always the same, a frustrating jumble of fragments that never cohered into a single intelligible sentence. The lock would not turn. This repeated failure forced a pivotal shift in thinking. Perhaps the encryption was not simple, but brilliantly complex. Consider the polyalphabetic cipher, a system where the relationship between the real letter and the secret symbol changes constantly, guided by a keyword. In one paragraph, the Voynich glyph for flower might mean L. In the next, that same glyph could now stand for R. This creates a layer of security that simple substitution lacks, a dancing code that evades basic frequency analysis. An even more intricate idea is the cipher of a cipher, where a meaningful text is first encoded, and then that encoded text is translated into the manuscript's unique script, creating a double veil. There is also the possibility of a physical key, like a Cardan grill, a sheet of parchment with holes cut in it. When this mask is placed over a page of seemingly random text, the letters visible through the holes spell out the true message. Computer scientists have become the modern lockpicks, designing algorithms to test billions of these possible combinations at speeds unimaginable to a human analyst. These digital assaults have occasionally produced flashes of something recognizable, a possible plant name or a short phrase, but these fragments collapse under scrutiny. They fail to build into a consistent, grammatically sound translation that spans multiple pages. This grand cryptographic impasse leaves us with two equally staggering possibilities. The first is that a 15th century mind devised an encryption method so advanced that it continues to outsmart our most powerful computers, a concept that rewrites our understanding of medieval intellectual history. The second, and far more unsettling possibility, is that we have been trying to pick a lock that was never there to begin with. If the cipher hypothesis cannot provide an answer, then the search must expand beyond the realm of codes and into the very structure of human language itself, seeking not a key, but a lost linguistic fingerprint. The humming of a server farm replaces the rustle of parchment. This is the new frontier of the quest, where artificial intelligence is trained to think like a medieval mind. The application of machine learning to these ancient texts is not just a new tool, it represents a complete paradigm shift in how we approach the mystery. Researchers begin by feeding these algorithms a vast library of known languages, from medieval Latin and Old Czech to Hebrew and Arabic. The artificial intelligence absorbs the statistical rhythms, the grammatical skeletons, the hidden fingerprints of each tongue. Then it is set loose on the encoded script, tasked with a singular mission: to find echoes, to detect the faintest shadow of a familiar pattern in the sea of strange glyphs. In a landmark study from 2018, a team from the University of Alberta did exactly this with the Voynich Manuscript. Their algorithm, after scanning the text structure, proposed a startling hypothesis that the underlying language might be a form of encoded Hebrew. The model even ventured a partial translation, suggesting phrases that mentioned a farmer, light, and air. For a moment, it felt like the centuries-old door had finally creaked open. Yet the excitement was tempered by immediate and rigorous debate. This is the critical caveat of artificial intelligence in this field. These systems do not understand meaning, they calculate probabilities. They are brilliant at finding correlations in colossal datasets, but they cannot distinguish between a true linguistic signal and a compelling pattern found in pure noise. The proposed Hebrew translation, while fascinating, could not be consistently replicated or verified across the manuscript by human experts. It stood as a powerful hypothesis, not a definitive key. This illustrates the double-edged nature of the tool. Artificial intelligence's great strength is its inhuman capacity for scale and speed. It can test 10,000 linguistic models in the time it takes a scholar to carefully analyze 10 pages. It can hold the entire structure of 100 languages in its memory at once, searching for a match with relentless precision. Its weakness, however, is foundational. The principle of garbage in, garbage out still applies. If the initial parameters are flawed, if the question is asked incorrectly, the most sophisticated algorithm will simply produce a more elaborate form of nonsense. The output is only ever a suggestion, a new map drafted by a brilliant but literal-minded cartographer. It is then the human expert who must take that map and see if it corresponds to any recognizable terrain. This powerful collaboration between human intuition and machine calculation has pushed the investigation into fascinating new territory, but the core translation remains elusive. When even our most advanced pattern recognition engines struggle, it forces a profound strategic pivot. Perhaps we have been asking the wrong question of these books. If the text continues to guard its secret, maybe the answers are not in the words at all, but in the pictures that have been silently waiting beside them for centuries. Hungary in the early 19th century was a nation in search of its own past. It was within this fervent atmosphere of romantic nationalism that a small, handwritten volume surfaced from the private library of the Rohonc family. Known as the Rohonc Codex, this book presents a mystery that is both more intimate and in some ways more frustrating than the Voynich. With 448 densely packed pages, it feels less like a lavish encyclopedia and more like a personal devotional text or a manual. Its illustrations are not fantastical botanicals but crude, earnest drawings of soldiers, castles, suns, moons, and unmistakable Christian crosses. This visual familiarity is the Codex's first great deception. The images suggest a context we feel we should understand, a medieval European world of faith and conflict. Yet the text that surrounds them is a complete cipher, written in a flowing script from right to left. The script itself is an outlier. Where most alphabets use between 20 and 40 characters, the Rohonc system employs an astonishing 150 distinct symbols. This immense variety immediately suggests a different kind of system entirely. Experts suspect it may be syllabic, where each symbol represents a syllable like bar or ton, or even logographic, where a single intricate glyph stands for an entire word or concept, like the characters in Chinese. This possibility transforms the challenge. Decoding it is not a matter of swapping letters, but of discovering an entire lost dictionary of ideas. The scientific approach here faces a unique obstacle, the problem of scale. For statistical analysis to be reliable, it needs a large body of text to find meaningful patterns. The Rohonc Codex, while substantial, may simply be too small a sample. The patterns researchers detect could be statistical phantoms, leading them down endless false paths. This scarcity of data has fueled a compelling and controversial theory among some Hungarian scholars. They propose the Codex is not a medieval relic at all, but a fabrication from their own 19th century. In this view, it is a pastiche, a work of Romantic-era forgery created to give the burgeoning nation a mysterious, ancient textual heritage. It would be a powerful symbol born from a desire for a deep past, even if that past was invented. Whether it is a genuine encrypted treasure or a brilliant historical hoax, the Rohonc Codex underscores a pivotal dilemma in this entire field. When a script has no recognizable siblings, no related alphabets to compare it to, how do you even begin? You cannot build a Rosetta Stone without a second, known language to serve as a guide. This profound deadlock forces a strategic retreat from the page itself. If the text will not speak, perhaps the world that created it still can. The investigation must widen, moving from the microscopic analysis of ink to the sweeping study of history, trade, and human migration. The world outside the book becomes its own kind of cipher. This is the practice of contextual archaeology, a meticulous effort to reconstruct the human ecosystem that could have produced such a singular object. Decoding is not just about letters on a page, it is about the lives that held the pen, the pressures that demanded secrecy, and the intellectual currents that shaped a unique mind. For the Voynich Manuscript, this means stepping into the early 1500s, a Europe simmering with new ideas and old fears. One compelling figure emerges from the historical record, Holy Roman Emperor Rudolf II. His court in Prague was a legendary cabinet of curiosities, a magnet for astronomers, alchemists, and collectors of the bizarre. The manuscript has been tenuously linked to his circle, suggesting it may have been crafted as a precious object of mystery for a wealthy, eccentric patron. This context of Renaissance curiosity provides a powerful motive. The book itself was the treasure, its value lying in its impenetrability. But other possibilities emerge from the shadows of that era. Could it have been the work of a persecuted religious sect, encoding heretical beliefs in a botanical disguise to avoid the scrutiny of the church? Or perhaps a brilliant, isolated scholar, like a nun in a remote convent, compiling a secret herbal knowledge deemed too powerful for common eyes? Each potential creator, from a merchant of secrets to a courtly entertainer, brings a different set of assumptions about the text's purpose. This historical detective work provides crucial constraints, acting as a reality check for more fanciful theories. For instance, any hypothesis suggesting the Voynich depicts plants from the Americas is immediately invalidated by the carbon dating, which places the book's creation decades before Columbus's famous voyage. The physical timeline of history fences in the realm of possibility. For the Rohonc Codex, the contextual search moves east, tracing the turbulent paths of religious dissenters and mercenary soldiers across 16th and 17th century Eastern Europe. Its crude drawings of crosses and castles suggest a world of faith and conflict, possibly created by a minority community needing to record its rituals in a script only its members could understand. This holistic view, weaving together politics, trade, technology, and personal motive, answers the most human question of all: why? Why go to such extraordinary lengths? The reasons could range from the practical, protecting a lucrative trade secret like a recipe for porcelain or a medicinal formula, to the profound, safeguarding spiritual beliefs that could lead to persecution, or simply to the artistic, crafting an object of wonder that commands awe and value. By mapping this lost world, researchers do not find a translation key, but they build the walls of the room in which the key must be found. They define the realm of possible meanings, which brings us back to the one element of these books that has always spoken directly: even if we do not understand its language, the art itself. A drawing can be a question posed in silent ink. When the text of these manuscripts remains stubbornly silent, the illustrations step forward as a parallel language, a system of symbols waiting for its own grammar to be discovered. This is the domain of art historical analysis, where every curl of a root, every arrangement of stars, is treated as a deliberate piece of data. The discipline of iconography, the study of symbolic imagery, becomes a vital tool. It asks not what the pictures are, but what they mean within the worldview that created them. Take the so-called biological section of the Voynich Manuscript. It depicts small female figures, often immersed in or connected by intricate tubes and vessels to celestial or organic structures. To a modern eye, it might suggest anatomy. But an art historian looks deeper, comparing these scenes to the visual vocabulary of the 15th century. Could they represent the medieval concept of the microcosm and macrocosm, the belief that the human body reflects the structure of the universe itself? Or are they diagrams of alchemical processes where the vessels are not biological but chemical, illustrating a spiritual transformation? The familiar yet bizarre zodiac fold-outs provide another clue. While the symbols for Taurus or Libra are recognizable, their arrangement in concentric, fluid charts is utterly unique. By placing these pages beside known astronomical diagrams from the same era, researchers can spot influences, perhaps from Arabic astrological texts, or identify deliberate, radical departures that signal a new or heretical system of thought. For a modern puzzle like the Codex Seraphinianus, the art historical approach shifts. Here, analysis focuses on its clear surrealist heritage, its parody of the cold, clinical style of a botanical or engineering textbook. The artist is using a visual language we understand, the language of science, to document a universe of pure imagination, forcing us to confront our own trust in authoritative imagery. Beyond style, physical science returns to aid the art historian. Advanced pigment analysis can identify the specific minerals in the paints. The presence of a rare blue made from lapis lazuli, for instance, would tell a story of immense expense and trade routes, potentially tying the manuscript to a wealthy patron or a specific artistic workshop. Ultimately, this visual investigation seeks to answer the most practical question of all. What was this book for? A volume filled with detailed drawings of pharmaceutical jars and distilling equipment strongly suggests a medical or alchemical manual. One dominated by complex, unique star charts points toward an astrological text, perhaps a personal guide for casting horoscopes. This creates a powerful, necessary feedback loop with the linguistic decipherment attempts. Any proposed translation of a plant's label must logically correspond to the illustrated plant's supposed properties. If a scholar claims a page describes a cure for fever, the plant depicted should align, however strangely, with known medieval febrifuges. The illustrations act as a grounding wire, a tangible reality check against the abstract whirlwind of cryptographic theories. They remind us that even the most baffling book was created by a human hand for a human purpose, rooted in the visual world of its time. A genuine investigation must always confront its own shadow. The most exciting possibility, that a manuscript holds profound lost knowledge, is balanced by a more cynical but equally important one, that it holds nothing at all. This is the hoax hypothesis, and for a scientist, it is not a dismissal but a foundational line of inquiry. The null hypothesis must be tested first. Could this entire beautiful, baffling object be an elaborate deception? For the Voynich Manuscript, history provides a tantalizing suspect. Edward Kelly was a figure straight from a Renaissance thriller, a known alchemist, medium, and confidant in Emperor Rudolph II's court. More importantly, he had a documented reputation as a forger of antiquities. Could a man like Kelly, understanding the emperor's insatiable appetite for mysterious curiosities, have crafted a completely invented book to sell for a princely sum. Science approaches this question forensically, searching for anachronisms, tiny cracks in the facade that would betray a later creator. The art style is scrutinized for elements that would be stylistically impossible in the early 1500s. The text is analyzed for statistical fingerprints that belong to a later era. This is where the earlier radiocarbon dating delivered its crucial verdict. It proved the parchment and ink were genuinely from the early 15th century, ruling out a modern, say 19th century, forgery. But it left a narrower window open, the possibility of a contemporary hoax. A clever fraudster in the 1520s, using materials of his own time, could still have created a nonsense book designed to dazzle a wealthy patron. How does science test for that? One powerful method returns to the statistical patterns within the text itself. If the manuscript were a simple, meaningless scrawl, its internal structure would be far more random. The work of researchers like Marcelo Montemurro, however, revealed something different. They found complex linguistic-like patterns in the Voynich, including a property called low conditional entropy. In plain terms, this means that given one symbol, you can predict the next with a reasonable degree of certainty, a hallmark of real human language, not random gibberish. This finding is a strong argument against a simple, careless hoax. It suggests that whatever the Voynich is, it was created with a systematic set of rules in mind. Proving deliberate fraud across 5 centuries is a monumental challenge. It requires evidence of intent to deceive for personal gain, a motive that is often the ghost in the historical record. This rigorous, skeptical lens is what separates romantic speculation from true decipherment. It ensures that the thrilling desire for a solution never overrides the quiet, stubborn voice of empirical evidence. By honestly weighing this possibility of a beautiful deception, the investigation maintains its integrity, cleanly setting the stage for a manuscript where the words are perfectly clear, yet their ultimate purpose dissolves into an even deeper kind of mystery. Sometimes the most important words are those we can almost understand. The Liber Linteus Zagrabiensis presents a unique and haunting form of mystery. It is not a book of secret codes or invented alphabets. In fact, its script is a clear, readable variant of the Greek alphabet, and scholars have confidently identified its language as Etruscan, the tongue of a powerful civilization that flourished in ancient Italy before Rome. The profound enigma here is one of cultural loss. We can pronounce the words, but their full meaning slips through our fingers like sand. This manuscript, whose name translates to the Linen Book of Zagreb, survives only because of a strange and poignant journey. It was not found in an Italian tomb or temple. Instead, it was discovered wrapped around the body of a woman in Egypt, a mummy from the Ptolemaic period. Someone, centuries after the text was written, cut the precious linen sheets of this ritual calendar into strips and reused them as burial cloth. This act of practical recycling, while devastating to the book's original form, is what preserved it from total decay. The dry Egyptian climate saved what time would have destroyed in Europe. So we have a complete text, the longest Etruscan document in existence, but it is a message from a world whose context has almost entirely vanished. The scientific challenge shifts dramatically. This is not cryptanalysis, but the slow, meticulous work of linguistic archaeology. Researchers are not looking for a key. They are trying to rebuild the entire lock, piece by tiny piece. Our knowledge of Etruscan comes primarily from short, formulaic funerary inscriptions on stone, epitaphs that give us names, familial relationships, and a limited vocabulary about offerings and remembrance. The Liber Linteus, by contrast, is a lengthy religious document, a ritual calendar that likely details ceremonies, deities, and offerings throughout the year. It contains words and grammatical structures never seen on a tombstone. How do you begin to translate such a text? The process relies on painstaking pattern recognition, and the few precious points of reference we have. For example, if a particular word appears repeatedly alongside a known god's name from other inscriptions, linguists can infer it might be a title or an associated ritual object. The names of months, identified by their order in the list and compared to later Roman calendars which borrowed from the Etruscans, provide another fragile anchor. Modern technology enters this delicate process as a powerful magnifying glass. High-resolution multispectral imaging can lift faded ink from the ancient linen, clarifying characters that have blurred over 2 millennia. Material analysis of the fabric and the carbon-based ink helps confirm its origin and age, ensuring the text is studied as a genuine artifact. But the most significant tool today is computational, falling into a field known as corpus linguistics. Scientists can digitize every known fragment of Etruscan text, from the Liber Linteus to the briefest epitaph, creating a searchable digital corpus. Powerful algorithms then analyze this limited dataset, searching for syntactic patterns, collocations of words, and statistical relationships that might escape the human eye. They can test hypotheses about grammar at a scale and speed impossible for a lone scholar. Does a certain suffix always indicate a future tense? Does a particular word order denote a question? The machine helps propose rules from the fragments. The Liber Linteus stands as a solemn reminder that a manuscript's silence can have different tones. Some books are locked by design, their secrets protected by cipher. Others, like this linen text, are locked by time, their meaning obscured because the living world that gave them voice is gone. Every translated phrase is a victory, a small window reopened into a lost culture's way of seeing the year, their gods, and their place in the cosmos. It represents a decipherment of a different order, one measured not in sudden breakthroughs, but in the gradual, collective effort to listen to a whisper that grows fainter with every passing century. This painstaking reconstruction from fragments leads us to consider an even more radical possibility. What if a manuscript's purpose was never to communicate with the future at all, but to serve a function so immediate and so personal that its meaning was meant to dissolve with its user? The digital corpus becomes a kind of linguistic echo chamber, a place where dead languages are taught to speak again. This is the meticulous work of computational linguistics, a field that treats words not as poetry but as data, searching for the hidden architecture of meaning. Imagine a vast digital library where every surviving word of Etruscan, from the Liber Linteus to the briefest tombstone inscription, has been carefully tagged and entered. This is the corpus, a searchable map of an entire lost world of communication. Researchers can then ask this database profound questions. They can search for every instance a particular word appears, see what other words consistently surround it, and begin to deduce its function. Does it always come before the name of a deity? It might be a verb for offering. Does it follow a list of numbers? It could be a unit of measurement. This statistical, evidence-based approach builds understanding from the ground up, one correlation at a time. For a script that is completely unknown, with no Rosetta Stone to guide it, the process becomes even more ingenious. Here, researchers must build the corpus from the manuscript itself. They feed every line of the mysterious text into a computer, which then performs a relentless analysis of internal consistency. The algorithm searches for patterns of repetition and variation. Do certain sequences of symbols appear over and over again, especially at the beginnings or ends of lines? These could be common words like the or and, or perhaps grammatical endings. Do specific clusters of symbols always appear next to a particular illustration, like a drawing of a plant or a star? This repeated association was the critical breakthrough in deciphering the ancient Aegean script known as Linear B. Scholars noticed that certain groups of signs consistently appeared beside ideograms, simple pictures of commodities like wheat, olive oil, and chariots. This context provided the first vital clues, allowing them to hypothesize that these sign groups represented the words for those items. It was the pattern, not a translation key, that opened the door. This computational method transforms the manuscript into a self-referential puzzle. The text must provide its own clues. By analyzing the rhythm of the symbols, where they cluster and where they stand alone, algorithms can suggest which marks might be vowels or consonants, which might be prefixes or suffixes. It is a painstaking process of building a grammar from scratch, using only the text's own habits as a guide. This approach does not deliver a sudden, dramatic translation. Instead, it slowly constructs a scaffold of probability, a statistical model of how this unique language might function. Each proposed rule, each hypothesized word meaning, is then tested against the entire corpus. Does it hold true across multiple pages? Does it create contradictions? This rigorous, iterative process is how a whisper from the past is amplified, not by guessing its secret, but by listening with immense patience to its inherent structure. Yet, even the most powerful pattern recognition faces its limits when the text is short, or the system is deliberately obscure. This constant tension between the promise of the algorithm and the silence of the page leads us to a pivotal question. What happens when science must look beyond the words and the pictures, to the very atoms that compose them? A single mind could never hope to see the whole picture. The quest to read the unreadable has evolved from the solitary genius in a candlelit study to a symphony of specialists, each listening for a different note in the same ancient melody. This is the power of the interdisciplinary team, the modern engine of decipherment. Imagine a single artifact arriving in a laboratory today. Its journey begins not with a linguist, but with a material scientist who takes a microscopic sample of its vellum, reading the atomic decay to anchor it in time. A chemist then analyzes the ink, identifying minerals that whisper of trade routes. An art historian decodes the symbolic language of its illustrations, while a cryptographer subjects its script to every known cipher model. A computational linguist feeds its patterns into vast digital models, and a historian provides the crucial map of the world from which it came. They do not work in isolation. They share data in real time, their findings circulating in a continuous loop of hypothesis and testing. This collaborative model is essential because a manuscript is not one puzzle, but a stack of interconnected ones. A breakthrough in one discipline can shatter a stalemate in another. For instance, the chemical identification of a specific, rare blue pigment derived from lapis lazuli in an illustration immediately tells a story of immense expense and long-distance trade. This could narrow the manuscript's probable origin to a wealthy, cosmopolitan center with access to such luxuries, perhaps a royal court or a major monastic scriptorium. That geographic clue, in turn, directs the linguist and historian to focus on the languages and cryptographic traditions that flourished in that specific place and time. Teams at institutions like the Voynich Library at Yale or research groups at the University of Bristol operate on this very principle. They understand that bias is the enemy of discovery. A cryptographer might become convinced a text is a complex cipher, while a linguist might see the ghost of a lost language. Only by forcing these perspectives to collide, to challenge and support one another, can a more holistic truth emerge. This approach recognizes the artifact in its full complexity, as both a physical object shaped by chemistry and craft, and an intellectual product born from a specific human mind in a specific cultural moment. It is a multi-layered construct and thus requires a multifaceted attack. This collective brainpower, this fusion of science and humanities, is now being directed at the most fragmentary whispers of the past, where even a complete page is a luxury. These seals are messages from a world that left no other voice. Carved from steatite, a soft stone hardened by fire, they are small enough to fit in the palm of your hand, yet they carry the weight of an entire civilization's silence. For over 4,000 years, the Indus Valley culture thrived along the rivers of modern-day Pakistan and northwest India, building meticulously planned cities with advanced drainage and bustling trade networks. Then, around 1900 BC, this sophisticated society faded from history, leaving behind its magnificent ruins and, most tantalizingly, thousands of these inscribed artifacts. The script they bear is concise and elegant, a flowing combination of abstract symbols and stylized pictographs, often accompanied by a beautifully carved animal like a majestic bull or a mysterious, single-horned creature scholars call the Indus unicorn. But here lies the core of the enigma. Where other ancient scripts cover temple walls or lengthy scrolls, the Indus texts are vanishingly short. The average inscription contains only about 5 symbols. The longest known text has just 26. It is as if we have recovered only the headlines of a lost newspaper or the brief labels on a society's filing system, with the vast libraries of context turned to dust. This extreme brevity creates the ultimate decipherment bottleneck. Without a longer text, how can anyone hope to find the rhythm of a language, the repetition of grammatical particles, or the narrative flow that betrays meaning? The scientific challenge is monumental, and it begins with a fundamental, unresolved debate. Are we even looking at writing? Some researchers argue the symbols are a true linguistic script, encoding the sounds of a spoken language, perhaps an ancestor of the Dravidian languages spoken in southern India today. Others propose a more limited system, suggesting the marks are non-linguistic signs denoting clan names, religious titles, or identifiers for specific trade goods, more akin to heraldic crests or property seals than to prose. This question of intent must be answered before translation can even be attempted, and science turns to the cold, clear logic of pattern recognition. In the absence of a bilingual Rosetta Stone, computational analysis becomes the primary tool. Researchers have painstakingly catalogued every known seal, creating a digital corpus of every sequence. They run sophisticated statistical tests like Markov chain analysis, which examines the probability of one symbol following another. In a true language, certain combinations are far more likely than others, creating a statistical signature of syntax. These models search for that signature, for the ghost of grammar in the short strings of symbols. They analyze where symbols tend to appear, if some are always at the beginning of a line, perhaps acting as a start marker or a title, and if others cluster near the depictions of specific animals. This contextual archaeology provides another layer of potential meaning. The animals on the seals are not random. The bull and the unicorn appear with striking frequency. Were these symbols of powerful families or guilds? Did they represent specific commodities in a vast trade network, a stamp of quality or origin pressed into clay tags attached to bundles of goods? The seals themselves, often found with a pierced boss on the back, were clearly made to be pressed into soft clay, suggesting a practical, administrative function. Yet the artistic care lavished upon them speaks of social and perhaps religious significance. Each line of inquiry, from statistics to archaeology, builds a fragile model of possibility. A researcher might propose, based on symbol distribution, that a certain mark acts as a word divider. Another might suggest, from the repetition of a symbol group across different seals, that it represents a title or a place name. But without a longer text to test these models against, they remain elegant hypotheses. The fragmentary evidence means that any claim of full decipherment is treated with extreme skepticism by the academic community. The process, therefore, is one of building a framework for a future discovery. Scientists are constructing the most robust statistical and contextual understanding possible, so that if a miracle occurs, if a longer inscription or that elusive bilingual text is ever unearthed, the community will have a prepared mind and a set of tools ready to receive it. This case stands as a humbling reminder of history's selective memory. A civilization can build cities that astonish the modern world, yet its voice can be reduced to a handful of symbols on a stone seal, a perfect code awaiting a key that time itself may have destroyed. The human mind is a relentless pattern-seeking machine. This fundamental cognitive drive is the silent engine behind every attempt to crack these ancient codes. We are neurologically wired to find faces in clouds, hear words in static, and impose order on chaos. An enigmatic manuscript presents the ultimate test for this instinct, a field of strange symbols that our brains cannot help but try to organize into a coherent message. This deep-seated aversion to uncertainty, this powerful need for narrative closure, is what transforms an academic puzzle into a cultural obsession. Psychologists call the thrilling moment of sudden insight the eureka effect, a burst of dopamine-fueled satisfaction that rewards the brain for solving a problem. It is this biochemical promise that keeps researchers at their desks for decades, and it is the same promise that captivates the public, drawing us into the mystery. We are not just observers, we are participants in a grand cognitive challenge. Laboratory experiments make this involvement clear. Scientists might show volunteers a page from the Voynich Manuscript alongside a sheet of completely random marks. Time and again, people will naturally and unconsciously impose more structure, more perceived meaning onto the Voynich symbols. They will report seeing repeated words, familiar letter shapes, or even vague thematic connections that are not present in the purely random script. This reveals a critical bias in the entire decipherment process. Our own brains are desperate to see a language, and they will often find convincing patterns in the noise. This cognitive lens also turns its gaze backward toward the original creator. What was the psychological intent behind such a work? Was the primary goal to communicate secret knowledge to a chosen few, using obfuscation as a protective shield? Or was the goal to create an aesthetic experience of the unknown itself, a beautiful object whose value lay in its perpetual mystery, like an intricate lock with no key? Perhaps the intent was even more personal, a meditative or ritual act of writing where the process itself held meaning, not the content. Understanding these possible mindsets becomes a powerful filter. It helps scientists weigh the probability of various theories against the cognitive constraints of the historical period. A proposed cipher that would require a 15th-century scribe to perform mental calculations equivalent to a modern supercomputer is not just historically unlikely, it is cognitively implausible. The human-centric approach grounds the search in reality. It reminds us that these are not alien artifacts, but products of human hands and human minds, shaped by the same cognitive tools we use today, just directed by a different set of intentions and cultural pressures. By studying how we think, we gain a clearer sense of how they might have thought, turning the mirror of inquiry back on ourselves to better see the shadowy figure writing by candlelight centuries ago. Certainty is a luxury the past rarely affords us. After centuries of analysis with the most sophisticated tools ever devised, a definitive translation of the Voynich Manuscript remains frustratingly out of reach. This is the frontier where scientific inquiry meets its own horizon, the point where the data grows thin and the shadows of lost context grow long. Some historical puzzles are intrinsically undecidable, not because they are poorly studied, but because the world that created them has receded too far. The specific combination of events, the personal intent of the author, the cultural shorthand understood by every contemporary reader, all of that is gone, leaving behind only the artifact itself. In such a domain, science cannot deliver the kind of absolute proof we might hope for. Its power lies in a different direction, in managing probability. It can tell us with high confidence what the manuscript is not. The carbon dating rules out a modern forgery. The complex statistical patterns argue against it being a simple, careless hoax. These are monumental negative findings, clearing entire forests of dead-end theories. Science can also build compelling, plausible scenarios, suggesting that the text behaves like a language or that its pigments point to a European origin. But it cannot, with the evidence at hand, force a single, closed solution that every expert will accept. This inherent uncertainty is not a flaw in the method, it is a reflection of reality. History is not a pristine laboratory experiment. It is a fragmentary and often chaotic record. Embracing this truth is a mark of intellectual maturity. It protects the field from latching onto enticing but premature solutions, those grand claims of decipherment that flash brightly but crumble under peer review. It keeps the conversation open, honest, and rigorously grounded. In a profound way, this sustained mystery is part of the manuscript's enduring value. It functions as a permanent catalyst, a puzzle that continuously attracts fresh minds from different disciplines, each applying new tools and asking new questions. The quest itself, the collective human effort to understand, becomes a meaningful story separate from any final answer. The manuscript's power may lie as much in the questions it perpetually asks as in any secret it might one day reveal. This honest acknowledgement of limits does not mean surrender. It simply redefines the goal from conquest to conversation, a sustained dialogue with an artifact from a world we can only partially reconstruct. And it is from this place of humble curiosity that we can reasonably ask, what comes next for these ancient enigmas? The next frontier of decipherment is not a library, but a quantum laboratory. Here, the very nature of computation is being reimagined, and with it, our potential to converse with the silent past. Quantum computing operates on principles that seem drawn from science fiction, using quantum bits or qubits that can exist in multiple states at once. For a cryptanalyst, this is revolutionary. A cipher that would take a classical supercomputer billions of years to crack by trying every possible key could, in theory, be solved by a sufficiently advanced quantum machine in a matter of days or hours. It would perform those astronomical calculations not in sequence, but in a kind of simultaneous superposition, exploring all possible solutions at once. This doesn't mean every manuscript will instantly give up its secrets. The technology is in its infancy, and the specific algorithms to apply it to historical ciphers are still being written. But the theoretical promise is staggering. It suggests that the most complex locks ever devised by a human mind may finally have a key forged from the fabric of reality itself. While quantum machines learn to think in new dimensions, our ability to see is undergoing its own quiet revolution. Hyperspectral imaging moves far beyond the capabilities of current multispectral techniques. Instead of capturing a handful of broad light bands, a hyperspectral camera divides light into hundreds of extremely narrow, precise slices across the electromagnetic spectrum. Each material, each ink, each stain on a parchment interacts with these slices in a unique way. This incredible sensitivity can detect chemical differences invisible to any other method. It could reveal the ghost of a completely erased passage, a first draft hidden beneath the final text, or a faint underdrawing that shows how the artist planned a complex illustration. It turns a single page into a deep, stratified archaeological dig of information, all without ever touching the fragile surface. Another transformative tool is X-ray fluorescence scanning, often called XRF. This device, which can scan an entire page, works by exciting the atoms in the ink and parchment. Each element responds by emitting a unique fluorescent signature. The scanner builds a precise map showing the distribution of elements like iron, copper, zinc, or lead across the page. Why does this matter? Different batches of ink, mixed at different times or in different workshops, will have slightly different chemical fingerprints. An XRF map could show if a single scribe used one consistent ink pot throughout, or if the elemental signature changes midway through a chapter, hinting at a pause in work, a new author taking over, or a later editor making revisions. It reads the biography of the book written in its own chemistry. Artificial intelligence, too, is evolving beyond simple pattern recognition. The next generation involves generative models, systems that don't just analyze data but learn to create it. Researchers could train such a model on all known 15th century scripts, art styles, and linguistic patterns. Then they could ask it to simulate the creation of a document like the Voynich Manuscript. By observing the rules the AI invents to produce a convincing facsimile, scientists might gain unprecedented insight into the possible processes, constraints, and intentions of the original creator. Was the text generated by a systematic algorithm, or does it require a more fluid, language-like structure to be convincingly replicated? These converging technologies promise a future where analysis is both profoundly powerful and completely non-invasive. The goal is no longer to simply read the words, but to reconstruct the entire story of the book's creation, from the sourcing of its materials to the very moment the ink dried on each line. Each page becomes a deep archive waiting for the right frequency of light, the right quantum calculation to finally tell its full story. The hidden rule is the real secret. This principle finds its perfect demonstration not in a manuscript of total mystery, but in one where the language is perfectly clear. In the library of the Elizabethan magician and advisor John Dee, among his thousands of volumes, sat a peculiar Latin treatise known as the Rohonc Book, or by its alternative title, Alderea. Lost for centuries and only rediscovered in the 1990s, this book presents a different class of puzzle entirely. You can read its Latin text, which discusses astrology, the names of spirits, and magical practices. The words are not the barrier. The true enigma lies in 36 enormous tables that punctuate the text, each a grid 36 letters across and 36 letters down, filled with dense, cascading sequences of letters that appear utterly random. They look like a monumental exercise in meaningless repetition, a cryptographic forest with no apparent key. For generations, scholars could only stare at these tables and wonder. Were they incantations? Were they celestial maps written in a code of letters? Or were they simply a monumental, elegant hoax? The Latin text offered no explanation, only the haunting presence of the grids themselves. This was not a problem of translation, but of reverse engineering. The question was not what do these letters mean, but how were they made? What process, what hidden machine of thought could produce such a vast and intricate pattern? The answer would require a new kind of key, one built not from linguistics, but from pure mathematics and processing power. Researchers turned the problem over to computers, writing programs to scour the tables for any mathematical signature, any statistical ghost of a rule. They searched for patterns along the rows, down the columns, across the diagonals. They looked for acrostics, for repetitions, for any crack in the facade of randomness. The breakthrough was slow and meticulous, a triumph of interdisciplinary patience. Historian Deborah Harkness, understanding John Dee's profound interests in angelic communication and Renaissance cryptography, provided the crucial human context. Mathematician Jim Reeds provided the analytical firepower. Together, they discovered that the tables were not random, and they were not a static code to be broken. They were generated. Each massive grid was the product of a complex, multi-step algorithmic process. It began with a short, hidden keyword, a seed. Then, through a specific and repetitive mathematical operation, a kind of autoregressive cipher, that seed was used to generate the first row of letters. The result of that row was then fed back into the algorithm to generate the next row, and so on, row after row, until the entire 36 by 36 grid was complete. Change the starting keyword, and you get a completely different table. The Rohonc Book's secret was not a message, but a method. It was a puzzle of process, a demonstration of a magical or philosophical principle where order emerges from a simple rule applied with perfect, relentless consistency. This case redefines what decipherment can be. Sometimes understanding a text is not about finding a hidden translation, but about uncovering the creator's hidden logic, the intellectual engine they used to build their mysterious world. It proves that some of history's greatest puzzles are not locked boxes waiting for a key, but intricate clocks whose true wonder lies in seeing the gears turn. Knowledge carries a profound responsibility, especially when it is wrested from the silent past. The exhilarating chase to decode an enigmatic manuscript inevitably leads to a quieter, more complex question. Once we can read it, what then? The scientific pursuit is not a neutral act. It is deeply entangled with ethical considerations that touch on ownership, respect, and the very soul of cultural heritage. Who truly owns the story a 500-year-old book finally tells? If the Voynich Manuscript were conclusively translated tomorrow, would the answer belong to the academic institution that houses it, the researchers who cracked the code, or to humanity itself as a shared piece of intellectual history? This question of custodianship becomes even more delicate if a text can be linked to a specific modern community. Imagine a scenario where statistical analysis or newly uncovered historical records firmly connects a mysterious codex to the cultural ancestors of a present-day indigenous group. The decipherment then transforms from an abstract academic puzzle into a matter of cultural patrimony, raising urgent issues about who has the right to interpret, control, and benefit from that reclaimed knowledge. The scientific process itself operates under a primary ethical commandment: do no harm. These manuscripts are not just data sets, they are fragile, unique witnesses to history. Every analysis must prioritize non-destructive methods. Techniques like multispectral imaging, X-ray fluorescence scanning, and even the handling of micro-samples for carbon dating are conducted with meticulous care, designed to extract information while leaving the physical object intact for future generations of scholars and for the simple human wonder of seeing the real thing. This preservation is a debt owed to both the past and the future. Beyond the physical artifact lies a more philosophical dilemma. Does solving a mystery diminish its power? For centuries, the aura of the unknown has been part of these books' identity and their draw. They function as mirrors for our curiosity, as permanent reminders of history's vast silences. There is a legitimate concern that full decipherment could, in a sense, flatten a multidimensional object of wonder into a single, settled narrative, a historical document whose magic is replaced by mere fact. Some cultural traditions also hold that certain forms of knowledge are sacred or restricted, not meant for universal publication. A respectful approach requires scientists and curators to listen, to balance the relentless drive for empirical answers with a deep consideration for these intangible values. It means proceeding with humility, recognizing that some questions may remain respectfully unanswered, or that answers may be shared in ways that honor their original context. This ethical framework is not a barrier to discovery, but its necessary foundation. It ensures that the quest to hear the whispers of the past is conducted not as a conquest, but as a careful, responsible conversation, one that respects both the message and the profound silence from which it emerged. The manuscript's greatest puzzles are no longer solved in solitude. Across the globe, in homes and coffee shops, a new kind of scholar is at work. They are programmers, linguists, artists, and curious minds of every background, all connected by a digital thread to history's most stubborn codes. This is the power of citizen science, a collaborative model that has shattered the walls of the traditional academy and invited the world inside. Online platforms like the dedicated Voynich Manuscript Forum or the Zooniverse project have become virtual laboratories where thousands of volunteers can examine ultra-high-resolution scans, tag recurring symbols, or run their own computational analyses. This collective intelligence operates on a simple, profound principle that a novel perspective, unburdened by a field's established assumptions, can sometimes see the pattern everyone else has missed. It is the intellectual equivalent of searching for a lost key with 10,000 pairs of eyes instead of 10. This democratization of research transforms the public from passive observers into active participants. When a library like Yale's Voynich or the British Museum digitizes a manuscript and releases it online for free, they are not just preserving it, they are releasing it into the wild of human curiosity. A retired engineer in Tokyo might notice a subtle ink smudge pattern suggesting a change of pen. A high school student in Brazil might write a simple program to test a new statistical model on the text. A botanist in Sweden might see a forgotten parallel between a Voynich illustration and a known medieval herbal. Each of these contributions, no matter how small, adds a data point to the collective effort. Of course, an open call for ideas generates a tremendous amount of noise alongside the signal. The forums buzz with fringe theories, from extraterrestrial origins to lost Atlantean languages. Yet this vibrant, sometimes chaotic, discourse is a feature, not a bug. It forces professional researchers to articulate their methods and defend their conclusions with greater clarity. It ensures that no possible avenue of inquiry, however unconventional, goes entirely unexplored. Most importantly, this engagement turns a centuries-old artifact into a living, breathing puzzle for our time. It demonstrates that history is not a closed book written by experts, but an open invitation, a participatory endeavor. The sustained public fascination generated by this access is itself a powerful force. It keeps these manuscripts in the cultural conversation, which in turn helps secure funding for the expensive, high-tech professional analyzers like particle accelerator studies or advanced pigment mapping. The amateur sleuth and the university professor are now part of the same ecosystem, one fueled by a shared, relentless drive to listen. And as this global conversation continues, it raises a final, reflective question about the nature of the quest itself, one that looks beyond any single solution to the deeper meaning of the search. Gold brocade and abstract symbols hid a society's secret gaze. In an archive in the former East Germany, a peculiar volume from the 1750s waited, its 105 pages bound in luxurious, gold-threaded fabric. Known as the Copiale cipher, its pages were filled with a baffling mix of elegant Roman letters and mysterious, invented glyphs, a beautiful lock with no key in sight. For decades, it resisted every traditional approach, its meaning sealed as tightly as the society that produced it. The breakthrough would not come from a lone genius, but from a novel partnership between human intuition and machine intelligence. An international team of computer scientists and linguists, led by experts like Kevin Knight, approached the manuscript as a data problem. Their first step was computational separation. Using algorithms, they sorted the cipher's characters into distinct sets, isolating the Roman letters from the abstract symbols. This simple act of digital organization revealed a critical pattern. The Roman letters appeared with a strange, uniform randomness, while the abstract symbols showed the complex statistical rhythms of a real language. This led to a brilliant and counterintuitive hypothesis. What if the plain, readable letters were the deception? The team proposed that the Roman characters were nulls, meaningless placeholders inserted to confuse and distract anyone trying to break the code. The true message was written entirely in the strange, abstract symbols. With this guiding insight, the powerful statistical tools had a clear target. The researchers focused only on the symbols, treating the spaces between them as likely word breaks. They then compared the frequency and distribution of these symbols to the statistical fingerprints of known 18th century European languages. The patterns pointed compellingly toward German. Once this linguistic anchor was set, the cipher began to unravel, revealing not a treatise on state secrets or hidden treasure, but something far more unexpected: the detailed rituals and internal politics of a German secret society with a fascinating obsession: ophthalmology, the study and surgery of the eye. The decoded pages describe initiation ceremonies involving symbolic eye operations and the washing of an initiate's eyes with a cloth, rituals that underscored the group's belief in enlightened vision, both literal and metaphorical. This was a society that saw physical sight as a powerful analog for intellectual and spiritual insight. The Copiale cipher stands as a textbook triumph of modern decipherment. It was not a brute force computational victory, but an elegant dance. Human creativity provided the crucial hypothesis that the obvious letters were nulls, and machine analysis provided the massive statistical verification. One without the other would have failed. This case is a beacon, a proven roadmap showing that even the most ornate historical locks can open when we combine the pattern-finding power of computers with the contextual, imaginative leap of the human mind. It proves that secrets, no matter how carefully encoded, can still find their voice. The blueprint for decipherment is not a single tool, but a scaffold of logic built around the artifact itself. It begins with the most fundamental question of all: is this object authentically from the time it claims to represent? This first step, material authentication, uses science like carbon dating and pigment analysis to build an unshakable foundation of fact. It confirms the age of the vellum, identifies the ink's chemistry, and ensures the investigation is not chasing a clever modern forgery. With the physical book anchored in history, the next phase is digital liberation. Every page, every faint pencil mark, every microscopic stain is captured through high-resolution multispectral imaging, transforming the fragile physical object into a robust, endlessly shareable dataset. This digital twin becomes the shared workspace for a global team of experts. Only then does the research branch into parallel streams of inquiry. Historians dive into archives, reconstructing the world that could have produced such a text, while art historians decode the symbolic language of its illustrations, searching for cultural echoes. Meanwhile, linguists and cryptographers subject the digitized script to a battery of statistical tests, mapping character frequencies and searching for the ghost of grammar or the signature of a cipher. This stage is about classification, not translation, determining whether the text behaves like a language, a code, or something else entirely. The most powerful modern engines, artificial intelligence and computational models, are then brought to bear on this consolidated data. These systems can test thousands of linguistic hypotheses in moments, searching for patterns too subtle for the human eye, or simulating the creation of the text to reverse engineer its rules. Yet the crucial moment comes in synthesis. A breakthrough in one field must illuminate a finding in another. Does the chemical signature of the ink point to northern Italy? Then the linguistic model should focus on Romance language patterns from that region. Does the art suggest an alchemical manual? Then any proposed translation must yield words related to processes and substances. This constant cross-checking prevents the research from spiraling into isolated, unverifiable theories. Finally, any emerging solution is subjected to the crucible of peer review and public scrutiny, tested by experts across disciplines and by the collective curiosity of global citizen scientists. This structured, multi-pronged methodology transforms the quest from a romantic gamble into a rigorous conversation. It acknowledges that a single key is rare, but that by patiently listening from every possible angle, we can sometimes hear the past begin to whisper. That final, unanswerable question is the very source of their power. A perfectly solved manuscript becomes a historical document, its secrets filed away. But an enduring mystery remains alive. It continues to ask, to challenge, and to reflect. In their stubborn silence, these books become something far greater than the sum of their vellum and ink. They become mirrors. When we stare into the swirling glyphs of the Voynich or the earnest symbols of the Rohonc Codex, we are not just looking at a forgotten language. We are seeing the reflection of our own relentless curiosity, our own frustration with the limits of understanding, and our profound awe at the sheer creativity of a human mind, whether it was meticulously documenting reality or ingeniously constructing a fantasy. Each manuscript is a singular time machine, but not one that transports us to grand battles or royal courts. It connects us intimately and directly with the intellectual struggle of a single individual. We are witnessing the moment their pen touched the page, a moment of thought made permanent, even if we cannot fully comprehend the thought itself. This is why the scientific quest to decode them is so compelling. It is not a cold technical exercise. It is a grand, multi-generational conversation with the past. We are using particle accelerators and artificial intelligence, tools the original scribe could never have dreamed of, to lean across the centuries and whisper the most human of questions: what were you trying to say? The pursuit reaffirms a profound truth that curiosity for its own sake has immense value. The drive to know, even in the face of likely failure, is a defining human trait. This quest demonstrates that history is not a static, closed record of facts. It is a dynamic and living puzzle. The boundaries of our understanding are not fixed walls, but ever-expanding horizons, pushed outward by the powerful marriage of humanistic inquiry, the deep study of culture and context, and relentless technological innovation. And in this space, the mystery itself transforms into a cultural artifact. It inspires novels and symphonies, paintings and films. It fuels online forums and citizen science projects, creating a global community united by wonder. The manuscript's greatest gift may not be a hidden recipe or a lost history, but the perpetual spark it provides, a silent reminder that some questions are so beautiful, they are worth asking forever. This journey reveals a thrilling truth about our own moment in history. We are living in a golden age of listening, where the quietest whispers from the past can finally be amplified. The quest to read the unreadable has forged a new kind of scholar, one who is as comfortable with a Python script as with a paleography chart, who understands that the story of a book is written in both its poetry and its protons. We have seen how a speck of vellum can anchor a mystery in time through carbon dating, how multispectral imaging can resurrect faded ink, and how artificial intelligence can search for linguistic ghosts in a sea of glyphs. These are not separate tools, but parts of a single, interdisciplinary engine of discovery. The real breakthrough is not a single eureka moment, but the cumulative power of this collaboration, where a chemist's finding about ink informs a historian's search, which then guides a computer scientist's model. It is a conversation across centuries and disciplines. Yet, for all our technological prowess, these manuscripts teach us a profound lesson in intellectual humility. Some doors may remain closed, not because we lack cleverness, but because the world that built them has receded beyond our full reconstruction. That is not a failure, but a different kind of understanding. It teaches us to value the question as much as the answer, to see that the sustained pursuit of a mystery is itself a meaningful human endeavor. These books challenge us to look at history not as a shelf of settled facts, but as a living, breathing puzzle, an invitation to wonder. The dialogue between their creators and our curiosity is the real story, a testament to the unbroken human drive to seek, to know, and to connect. If this exploration into the science of secrecy has sparked your curiosity, consider subscribing for more journeys into the puzzles of our past. And we would love to hear your thoughts. Which of these enigmatic manuscripts captivates you the most? Share your theories in the comments below. because the greatest discoveries often begin with a simple, shared question.